Hello. Today we're going to talk about Topic 4, Section 8, the binomial distribution. So your cognitive starts off with this picture. And, well, the binomial distribution is usually described as success or failure. So I guess successful lands on the rock, failure does not land on the rock. There are two outcomes. I would have probably described it as, flipping a coin. You either get heads or tails. So you can also describe that as getting heads or not getting heads. Okay? Rolling a dice, getting a 1, not getting a 1. Okay? So you have two options. All right? And the probability of them together is always 1, right? That's your only outcomes. So let's know our notation. Okay, B denotes that it's a binomial distribution. Okay, yes, there is something else called a geometric, but right now we're doing binomial. N is the number of trials, and B is the probability of success. Now, Q usually represents the probability of failure, so therefore this, again, remember, probability of success plus the probability of failure equals 1. Therefore, we can write it like this. Okay, you should know to get the other one, it's just 1 minus. Now, the mean expected value, the average value you would expect to get, is the number of trials times the probability of success. Now, the standard deviation is taking the square root of the number of trials times the probability of success times the probability of failure. You need to be able to read that and understand what those variables mean, okay, and how to plug in the numbers. All right, so now let's do an example. We can use the formula, however, with A and I, you can use your calculator. So how we do that is we first start with, we want the probability that 2 are incorrect. Okay, so 8 assignments are selected. You want to know what are the chances that 2 of them are incorrect. It could either be the first one and the 8th one, the second and the 4th, the first and the second. It doesn't matter. We want 2 that are incorrect. So we're going to use the binomial PDF. This is on our calculator. So let me grab my calculator. Now, where you go is, see, is it stat, test, nope, I lied, second vars. Yes, there we go. Sorry, I forgot. So you go to second vars, so we're going to distribution. You're going to scroll down or scroll up. We're going to binomial PDF. Make sure you go to PDF. Okay, now this is what we type in. Luckily for the 84, it tells you what the values are. If not, you have to just know them in order. It always starts with the number of trials, so that's 8. The probability of success, so in that case, it would be 0.25. And our success here being incorrect, right? Because we want it to be incorrect. I know that sounds weird, but think about what we want to happen. Now, the X value is 2 assignments. All right. We plug that in and notice how it is written. So you want to put it as 8.25 and then 2. This is the number of trials. This is the probability of success, and that is in what you want. Okay, I think that's how they describe it. How many you want. Well, I guess it should really be how many. All right. my goodness, get it together. All right, the next one is a little bit different, all right, because here we want at least 2 are incorrect. So we want the probability that 2 is correct plus the probability that 1 is correct. I'm sorry, at least 2. So more than 2. So probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of 6. Ooh. I hope you're getting the idea here. This sounds awful, doesn't it? Yeah, I really don't want to figure out each one of these probabilities, right? Okay, so notice we've listed everything but 0 and 1, right? Because if we also had plus the probability of it being 1 plus the probability of it being 0, that would equal 1. So why don't we get these values first? Okay. So essentially I want the probability of 1 plus the probability of 0. Okay, so 1 or less. We can do, and then we take that value and subtract 1. So again, we're doing 1 minus the probability that x is less than or equal to 1. Okay. What's great is we can actually use our calculator again to calculate this value. When we have an inequality, we're going to use CDF. So we do 1 minus the binomial CDF. That's an inequality. Okay. And then we do the number of trials, the probability of success, so getting something incorrect, and we want 1 or less, so we put 1. Okay, it always does less than, so remember we wanted the greater than, that's why we have to do 1 minus that probability. Okay, now you want to use the calculator. Oh, we never put the answer to that. So the answer to that one is 0.311. So let's do second vars. Scroll down to binomial CDF. 8 trials, 0.25. X value is 1. Now, the probability of that happening is 0.36. Now, we want 1 minus that, so 1 minus our answer, and that's our probability. All right. So, the answer for part A is the probability, so we'll put it as a decimal, 0.311. And the second one is 0.633 to 3 sig figs. Okay, so now do this one. Okay, here we have a binomial distribution. Okay, and here we want to find this probability. Okay, so what I would do, for example, 2, now this represents 11 trials. 0.25 is the probability of whatever is successful, whatever they consider success. And then we want to know, we want between 3 to 7 out of the 11 trials to be successful. Okay, we have to have exactly 3, 4, 5, 6, 7. Okay, so what we can do is we can do the probability of x being less than or equal to 7 and subtract the probability of x being less than or equal to 2. Okay, because think of like a number line. Okay, we want between 3 and 7. However, when I do the probability of this one, that's everything less than 7. Well, I only want this part. So I need to get rid of this. So I need to subtract this amount. So that way it's going to equal, that way it's going to equal this amount. Okay? All right. So if you plug that into your calculator, I believe you should get 54436. Yeah, so it rounds up. Okay, so a 54% chance that you're going to have the probability of success being equal to 3 and 7. Okay, so why don't you guys try these? I know I said that kind of weird. Try these and pause it, and then I'll explain it. Okay, so the expected number of respondents, that would be, let's see, 20 respondents, and we expect 45% to support, so that's successful. So that would be 0.45, and we would get 9. All right, next one, the probability to 4 decimal places that exactly 5 people support it. Okay, we could use the formula, but no way, Jose. I'm using binomial PDF. There are 20 people. We have a 0.45 probability, and we want exactly 5. So 4 decimal places would be 0.0365. Next one, that at least 2, so it could be more. All right, so it's easier to do subtraction there, so I would do 1 minus the, what am I spelling? Binomial is with a B, so binomial CDF, and I'm going to subtract the probability of it being at less than or equal to 1. So that would be 20, 0.51. And to 5 decimal places, that would be 0.99989. Okay. And now for the last one. Okay, so the probability to 2 decimal places that at most 6 people. Okay, so at most 6, so that is the probability of x being less than or equal to 6. So that's just binomial CDF, arguably easier than the third one. Okay, 20, 0.45, and 6. So therefore we get 0.13. Okay. Oh, I guess I should have written this one as a probability. Think of this one as being the probability of x being greater than or equal to 2. We always use binomial as less than, so that's why we have to rewrite that as 1 minus x is less than or equal to 1. Okay. All right. Again, it might help you to write it as something like that. So number 2 was the probability of x exactly equaling 5. So binomial PDF when it's exact. Okay. All right. Now, this is what you should know at the end of this unit. Hopefully, the end of this section. If you have any questions, please ask me in class. All right.